3I Atlas just passed Mars. Early images raise new questions. Avi just days ago, something quietly passed near Mars. No explosion, no dramatic glow, no spectacular tail lighting up the sky. In fact, if you weren't paying close attention, you might have missed it entirely. Its name is 3I Atlas, and it is only the third interstellar object ever observed entering our solar system from beyond the stars. That alone should make it remarkable. But what truly makes scientists pause is not what this object did, it's what it didn't do. Based on everything we know, an object like this should have shown signs of activity: gas, dust, a visible reaction to the sun's heat. Yet early images show something strangely quiet, almost indifferent, as it traveled through one of the most closely studied regions of our cosmic neighborhood. In science, moments like this matter. Because when observations don't match expectations, they force us to re-examine our assumptions. Is 3I Atlas simply an unusual natural object shaped by conditions we don't yet understand? Or is it a reminder that the universe may still hold surprises that challenge how we define the word ordinary? History tells us that some of the biggest discoveries began not with answers, but with uncomfortable questions. When an object enters our solar system from interstellar space, it carries with it a history that predates the sun, the earth, and everything we recognize as home. These visitors are not just astronomical curiosities, they are physical records of distant star systems, shaped by environments we can only infer from theory and indirect observation. This is why the arrival of 3I Atlas matters. It is not simply another rock drifting through space. It is a messenger, and like all messengers in science, its value lies in how carefully we listen to what it tells us and what it withholds. To understand why 3I Atlas has attracted attention, we must first understand what scientists expect from such an object. Interstellar objects are formed around other stars, expelled by gravitational interactions, and sent wandering through the galaxy for millions or even billions of years. When they finally pass near a star like our Sun, the increase in heat typically triggers visible activity. Ice sublimates into gas, dust is released, and a comet-like tail forms. This is not speculation. It is based on decades of observation of comets born within our own solar system. Nature, as far as we know, is consistent. And yet, consistency is precisely what seems to be missing here. Early observations of 3I Atlas show a trajectory and speed that clearly identify it as interstellar in origin. Its path is not bound by the sun's gravity in the way asteroids are. Its velocity is too high, its approach angle too steep. These are unambiguous measurements, not interpretations. Where interpretation begins is in its behavior. As 3I Atlas passed near Mars, a region of space where our observational capabilities are exceptionally strong, scientists expected to see at least minimal signs of activity. Instead, the images revealed something remarkably subdued. There was no dramatic outgassing, no pronounced tail, no obvious interaction with solar radiation that would align with standard cometary models. This absence is not a flaw in the data, it is the data. In science, silence can be as informative as noise. When something does not behave as expected, it creates an anomaly, and anomalies are where progress begins. It is important, especially for a scientifically literate audience, to distinguish between uncertainty and ignorance. Scientists are not confused by 3I Atlas. They are challenged by it. There is a difference. Challenge invites refinement of models, reassessment of assumptions, and, occasionally, the expansion of what we consider possible. Ignorance, by contrast, closes doors. This object opens them. One possible explanation is that 3I Atlas is a dormant comet, an object whose volatile materials have already been depleted by repeated exposure to stellar radiation in another system. Such an object would appear inert, even when passing close to the sun. This is a conservative hypothesis, and it deserves serious consideration. Science always begins with the simplest explanation that fits the data, but simplicity is not the same as certainty. Another possibility is that the object's composition is fundamentally different from what we are used to observing. Our models of cometary behavior are built on samples drawn almost entirely from our own solar system. We assume, often unconsciously, that other star systems produce similar materials in similar proportions. That assumption may be convenient, but it is not guaranteed. 3I Atlas may be revealing a diversity of planetary formation that our theories have not yet captured. Still, there are aspects that remain difficult to reconcile even within these frameworks. The object's apparent lack of activity, combined with its motion and orientation, invites comparison to the first known interstellar visitor, Oumuamua. In that case, subtle non-gravitational acceleration was detected, motion that could not be fully explained by gravity alone. That observation sparked intense debate, not because the data were flawed, but because they resisted easy explanation. The lesson from Oumuamua is not that extraordinary explanations should be embraced uncritically. The lesson is that extraordinary data should not be dismissed simply because they are uncomfortable. Science advances not by defending existing beliefs, but by testing them against reality. When reality disagrees, it is reality that wins. This is where the public conversation often becomes distorted. The moment an object behaves in an unexpected way, the discussion polarizes. On one side are those who insist that there must be a perfectly ordinary explanation, even if we do not yet know what it is. On the other are those who leap to sensational conclusions, bypassing evidence in favor of narrative. Neither approach serves science well. A more productive stance is intellectual openness grounded in discipline. We must be willing to consider all plausible explanations, while demanding that each be supported by data. This is not a radical position. It is the foundation of scientific inquiry. And yet, it is often misunderstood as provocation. When Avi Loeb argues that we should consider the possibility of artificial origins for some interstellar objects, he is not claiming certainty. He is pointing out a logical asymmetry. We already know that technological civilizations can produce objects that travel through space. We are one such civilization. To exclude that possibility a priori is not conservative, it is restrictive. The correct scientific question is not, is this alien technology? But rather, what explanations are consistent with the data and which are not? In the case of 3I Atlas, we do not yet have enough information to draw strong conclusions, but we have enough to justify careful attention. The fact that this object passed near Mars without exhibiting expected behavior should motivate further observation, not dismissal. Fortunately, our observational tools are improving. Upcoming surveys, particularly those based in the UK and Europe, will dramatically increase our ability to detect and characterize interstellar objects. This matters not only for astronomy, but for our understanding of our place in the universe. Every interstellar object is a sample from elsewhere. Each one carries information about conditions beyond our solar neighborhood. Ignoring anomalies because they are inconvenient would be a missed opportunity, not just scientifically, but philosophically. There is also a cultural dimension to this discussion, particularly relevant to a UK audience with a long tradition of empirical inquiry. From Newton to Darwin, progress has often come from questioning assumptions that seemed obvious at the time. Gravity was not intuitive, evolution was not comfortable, yet both reshaped how we understand reality. The common thread was not boldness for its own sake, but fidelity to evidence. 3I Atlas invites us into that tradition. It does not demand belief, it demands attention. As scientists continue to analyze its trajectory, brightness, and physical characteristics, the story of this object will evolve. Some explanations will be ruled out, others will gain support. That is how science works, slowly, methodically, and often without dramatic resolution. But the real value lies not in the final answer, but in the process that leads us there. If history is any guide, the most important outcome may not be what 3i Atlas turns out to be, but what it forces us to reconsider along the way. As the discussion around 3i Atlas continues, it becomes increasingly clear that this object is valuable not because it offers immediate answers, but because it exposes the limits of our current understanding. In science, progress rarely arrives as a sudden revelation. More often, it emerges from tension, the quiet discomfort that arises when observations refuse to align neatly with theory. 3i Atlas exists precisely in that space. One of the most important questions raised by this object concerns detectability. For decades, astronomers assumed that interstellar visitors would be rare and fleeting, largely invisible unless they behaved like traditional comets. That assumption shaped how we designed our surveys and how we interpreted what we saw. But objects like 3i Atlas challenge that framework. If interstellar objects can pass through our solar system without dramatic signatures, how many have we already missed? And more importantly, how many are we still missing now? This question has profound implications. It suggests that our current inventory of interstellar objects may represent only a small and biased sample, those that happen to conform to our expectations. In other words, we may be detecting only the loudest visitors, while the quiet ones pass unnoticed. From a scientific perspective, this is deeply unsatisfying. Selection bias is the enemy of understanding. The solution is not speculation, but better observation. Fortunately, this is where astronomy is headed. Next-generation surveys, such as those planned in collaboration with European and UK institutions, are designed to scan the sky with unprecedented sensitivity and frequency. These instruments will not wait for objects to announce themselves with tails and flares. They will detect motion, trajectory, and subtle changes in brightness, the signatures of interstellar origin, regardless of behavior. If 3i Atlas teaches us anything, it is that the universe does not owe us convenience. It does not structure itself around our models or our instruments. We must adapt to it, not the other way around. That adaptation requires humility, a quality often overlooked in public discussions of science, but essential to its practice. There is also a deeper philosophical layer to this story. For centuries, humanity assumed that Earth occupied a special position in the cosmos. That assumption eroded slowly, replaced by the realization that we are part of a vast, dynamic universe governed by the same physical laws everywhere. Interstellar objects reinforce this lesson. They are tangible evidence that planetary systems interact, exchange material, and influence one another across immense distances. In that sense, 3i Atlas is not an outsider. It is part of a galactic ecosystem, one in which matter travels, evolves, and occasionally crosses paths with emerging civilizations like our own. This perspective reframes the question of extraterrestrial life. Instead of asking whether life might exist elsewhere, we begin to ask how connected the universe already is. This is where the conversation often becomes uncomfortable. The possibility that some interstellar objects could be artificial in origin is not inherently radical. What makes people uneasy is the implication. If technological artifacts can survive interstellar travel, then intelligence may not be confined to isolated worlds. It may leave traces. It may be detectable, not through radio signals or dramatic encounters, but through subtle anomalies that require patience and precision to recognize. Still, caution is essential. The history of science is littered with ideas that were appealing but unsupported. Responsible inquiry demands restraint. The correct approach is not to promote extraordinary explanations, but to resist the temptation to exclude them prematurely. That distinction is subtle but crucial. When we examine 3i Atlas, we must ask what kinds of evidence would be required to support different hypotheses. What measurements would confirm a purely natural origin? What signatures would be difficult to reconcile with known astrophysical processes? These are empirical questions, not ideological ones. They can be answered, eventually, through observation and analysis. In this regard, the role of public discourse is important. Science does not exist in isolation. Funding decisions, research priorities, and institutional support are influenced by public understanding and interest. A scientifically literate audience, such as the one found in the UK, plays a vital role in sustaining long-term inquiry. Curiosity, when informed by critical thinking, is not a liability. It is an asset. There is also a generational aspect to consider. Younger audiences, raised in an era of rapid technological change, are often more comfortable with uncertainty. They understand that progress involves iteration, revision, and occasional failure. For them, the mystery of 3I Atlas is not frustrating, it is motivating. It represents an open question in a universe that still has room for discovery. This attitude aligns well with the scientific method. Answers are provisional. Models evolve. Certainty is earned slowly, not declared early. If anything, the refusal of 3I Atlas to conform to expectations is a reminder that nature is the ultimate arbiter of truth. As future data arrive, the narrative will likely become less dramatic and more precise. Some hypotheses will be discarded, others will be refined. Perhaps 3I Atlas will eventually fit comfortably within an expanded natural framework. Or perhaps it will remain an outlier, a statistical anomaly that resists classification. Either outcome is valuable. What would be truly disappointing is if we chose not to look closely enough to find out. The broader lesson here extends beyond astronomy. It speaks to how we engage with the unknown. Do we approach it defensively, protecting our assumptions? Or do we approach it with disciplined curiosity, willing to be surprised but committed to evidence? History suggests that the latter path, though slower and less comforting, leads to deeper understanding. In the end, 3I Atlas is not demanding belief in any particular conclusion. It is offering an invitation to observe more carefully, to think more broadly, and to remember that discovery often begins at the edges of what we expect. The universe is under no obligation to be familiar. Our task, as scientists and as a society, is to meet that unfamiliarity with rigor rather than fear. Whether 3I Atlas turns out to be a relic of an ancient star system, a fragment shaped by unknown processes, or something that forces us to revise our categories entirely, it has already served a purpose. It has reminded us that science is not a catalog of facts, but a living process, one that thrives on questions, not conclusions. As we reach the end of this discussion, it is worth remembering that objects like 3I Atlas do not owe us clarity. The universe rarely presents its mysteries in neat, well-labeled forms. More often, it offers subtle signals, quiet inconsistencies that challenge what we think we know. And those moments, when observation refuses to align with expectation, are not failures of science. They are its starting points. 3I Atlas may eventually be explained as a natural object with unusual properties, shaped by conditions far beyond our solar system. Or it may remain an outlier that forces us to rethink how interstellar objects behave. Either way, its true importance lies not in the conclusion we reach, but in the questions it encourages us to ask along the way. Science advances not through certainty, but through careful doubt. What matters now is how we respond. Do we look away once the headlines fade, or do we continue to observe, analyze, and refine our understanding? History shows that some of the most meaningful discoveries emerged from sustained curiosity, supported by communities willing to engage thoughtfully with the unknown. This is where you come in. If discussions like this matter to you, if you believe that the universe is still revealing its story, one anomaly at a time, then I invite you to be part of that conversation. Share your thoughts in the comments. What do you think 3I Atlas represents? an unusual natural visitor, or a reminder that we have more to learn than we often assume. If you found this analysis valuable, consider liking the video and subscribing to the channel, not for sensational answers, but for careful, evidence-based exploration of the questions that shape our understanding of the cosmos. The search for knowledge is not a solitary effort. It is a shared journey, and it continues with each question we are willing to ask. 3I Atlas just passed. Mars, early images raise new questions. Avi.